Welcome to Logarithms Part 3, Applied Electronics. So the noise level of a telephone line used for a wired music program is 60 dB down from the program level of 12.5 milliwatts. How much noise power is represented by this level? So we know that our gain, our dB gain formula is equal to 10 log, and we can put that in terms of noise over the program noise. Power noise over program power. And we know that we're 60 dB down, so that's minus 60 dB is equal to 10 log of the program noise or power noise divided by 12.5 milliwatts, which is our normal program level. And we know that log n is equal to x and 10 to the x is equal to n. So now we've got our, we've divided the 10 across, we've got minus 6. So we've got 10 to raised to the minus 6 is going to be equal to our P noise divided by 12.5 milliwatts. So our program noise at 60 dB down should be equal to 12.5 nanowatts. All right, an amplifier has a normal output of 30 watts, and a selector switch is arranged to reduce the output in 5 dB steps. What power output corresponds to the reductions of 5, 10, 15, 20, 25, and 30 dBs? Okay, so we know our formula is our gain in dBs is equal to 10 log of P out over P in. We can divide that across, and we've got now our gain in dBs divided by 10 is equal to log of P out divided by 30 watts. So now if we take 1 times 10 raised to the delta dB divided by 10, we get our P out over 30 watts. So now we're going to solve that equation in terms of P out. And now the delta dB is our 5, 10, 15, 20, 25, 30 reductions. So because they're reductions, they're going to be minus dB. And we can now solve for P out at minus 5 dB. And put it into that formula. And we're going to do the exact same thing for minus 10, minus 15, and minus 20, just in the delta dB part of the formula. Just put those numbers in. And you see that at minus 5 dB we get 9.487 watts. And at minus 10 dB we get 3 watts. And minus 15 dB we get the 0.9487 watts. And you can see the pattern now at minus 20 dB we're at 0.3 watts, and then 25 dB down we've got the 0.0948, and at 30 dB down we're at 0.03 watts. All right, a video tuner amplifier has an input impedance of 300 ohms and an output impedance of 3.5 k ohms. When a 300 millivolt signal is applied at the input, a 250 volt signal appears at the output. What is the voltage gain? So voltage gain is V out over V in. It's the ratio. And we can put 250 volts divided by 300 millivolts. That gives us a voltage gain of 833.333. Next question is, what is P out? Well, power out is equal to V squared divided by R. Our voltage is 250, so 250 squared divided by the Z out, or the output impedance, which is 3.5 k ohms, gives us a power out of 17.857 watts. Now, what is the gain in dB? Because the input and output impedances are not matched, we have to use the power formula to calculate the dB. So we know that our dBs are going to be equal to 10 log times the power out over power in. We've got our power out at 17.857 watts. Now we need to find our power in, which is our V squared divided by R. So we're going to use our voltage in, 300 milliwatts squared, divided by our Z in, our input impedance of 300 ohms. And we're going to divide 17.857 watts by that number, take the log of it, multiply that by 10, and that gives us our gains in dB of 47.75 dBs.